Okay, so now let's talk about the reactions of lipids. And in particular, we're not talking about lipids as a whole. We're really focusing on fatty acids and these triacylglycerols. Okay. First of all, there's actually a lot of overlap between what we already learned. The first reaction we're going to learn about is a hydrogenation reaction where we use H2 and some sort of a palladium or nickel catalyst. And that has the effect of reducing the double bonds. Remember, we talked about hydrogenation when we talked about alkenes. And what we're going to do is add a hydrogen to each one of those double bonds, right? So this hydrogen is being added to either side of that double bond. And in effect, we reduce our alkene to an alkane, or we go from double bonds to single bonds. So what does this mean in the scheme of our discussion of fats and fatty acids? That means that hydrogenation will take you from an unsaturated fat to a an unsaturated fatty acid to a saturated fatty acid, or an unsaturated triacylglycerol to a saturated triacylglycerol, right? And there were those characteristics. We talked about how oils contained more unsaturated fatty acids and were thus liquid at room temperature, whereas if we hydrogenated it, we would get these saturated fatty acids, which are then solids at room temperature. So which one would what would we expect to get from the complete hydrogenation of glyceryl trioleate? Okay, so glyceryl trioleate, remember that that's going to be a triacylglycerol. It's going to contain so the glycerol component, then you have an ester bond to these fatty acids. Which fatty acid are we talking about? Well, the trioleate lets us know that we're talking about oleic acid. Oleic acid has 18 carbons and 1 degree of unsaturation. So this isn't really what the problem asked for, but I'm still going to go ahead and draw it all out. This is my carbonyl carbons, then a chain of 7, carbonyl carbon. I guess I can do the whole thing. I'm just going to build one unit, but I'll go ahead and draw the whole thing out. 1, 2, 3, 4, 5, 6, 7. Then we have our double bond. Then I believe it was 5. Oh no, another 7, and then the methyl group. So 1, 2, 3, 4, 5, 6, 7, and then our methyl group. Right, so it's this. I guess I can actually cheat. Copy. Cool. So this is what we're starting out with. This is our glyceryl trioleate. What's going to happen when we hydrogenate this? Right? We're effectively just going to be reducing all of these double bonds to single bonds, which means that we're going to be going from being this 18:1 ratio to an 18:0 ratio. So we're going to convert our oleic acid into stearic acid. So what we would get is glyceryl tristearate. There should be a space here. This is a typo. Should be a space between those. But anyway, this is the correct answer. Where now all of a sudden we're going to get this 18 carbon chain, but it's going to be completely saturated, not have any degrees of unsaturation. Draw the condensed structural formula for the product of tripalmitalate that undergoes hydrogenation. So how do we figure this out? We're again going to find the palmitalate would correspond to palmitoleic acid, which has a 16:1 ratio. Well, what happens if I reduce all those double bonds? Now I'm just at palmic acid, which has 16 carbons but 0 double bonds. So this would be, sort of do it without the cheating here or without looking at the answer. I'm again going to include all my esters. And now I'm going to have 16 carbons with no degrees of unsaturation. So 1, 2, 3, 4, 5, 6, 7, 8. Okay, and if I was, doing a mastering chemistry problem or something, I would want to make sure that indeed I had 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16 carbons on each one of those fatty acid chains. All right, so hydrolysis is, we talked about the hydrolysis of esters before, right? So what happens when we take an ester and we hydrolyze it in the presence of acid? We break it into its carboxylic acid components and its alcohol components. So that's going to be the same thing here. We're going to see that we take a triacyl glycerol, and in the presence of acid and water, we break it up into the carboxylic acid component, which we call fatty acid, and the alcohol component, which is specifically glycerol in these triacyl glycerides. Oh no, they are glycerols. Okay, sorry. Okay, so again, just like we saw before, where we're going to cut it is at that ester bond between the oxygen and the carbonyl carbon. And so what that's going to do is break it up again into glycerol and all the different fatty acid components. So we go from being glycerol tripalmitate to glycerol and 3 palmitic acid molecules. Saponification is another way of cleaving those bonds in the exact same place, but using bases. And remember that instead of carboxylic acids, what we get is the salts of the carboxylic acids, or what we call carboxylate salts. Now, because we're talking about fatty acids, they're going to be fatty acid salts. Right? So we have our glycerol tripalmitate, and now we have sodium hydroxide. We again break it into that alcohol component glycerol, and now we're going to get 3 molecules of the fatty acid salt, sodium palmitate. And the reason that this gets its name, saponification, is because that's how soap was generated for forever. And why is this molecule here soap? Well, because it has this long hydrocarbon chain, which can interact with the nonpolar dirty molecules on our hand, but then it has this polar end to it as well, which can be carried away by the water, right? So if you think what's soap doing, it's picking up dirt from your hands, which is all this nonpolar material that didn't wash off from the water all by itself, picking that up and carrying it down the drain, because it has the one end that's nonpolar and then the one end that's polar. Okay, so these are the 3 main reactions that we're talking about here. Hydrogenation, all of these are we actually have covered before in organic chemistry. We're just applying it now to this new realm of biochemistry. Hydrogenation, reducing those double bonds to single bonds. In the world of lipids, that means going from an unsaturated fat to a saturated fat. Hydrolysis, right? So now breaking ester bonds. In the worlds of lipids, that means going from a triacyl glycerol to its fatty acid and its glycerol components. And saponification, basically the same thing, except for now catalyzed by a base. We're going from our esters, our triacyl glycerol, to the components glycerol and the fatty acids. But remember, because it's under basic conditions, we don't get the fatty acid. we get the carboxylate salt of the fatty acid, which we're going to call a fatty acid salt.